Now we start the serial communication. In serial communication, we are transferring data from one device to other. Okay, now you are transferring to with the help of two wires only. One is a transmission pin and second one is a reception pin. Now to support this serial communication, in the architecture of 8051 there are two registers. First one is a S buffer register. S buffer is nothing but serial buffer register which is supporting serial communication. Whatever data you want to transmit, it is first placed into the S buffer register. Means for example, this is our microcontroller and this is one of the peripheral. Okay, now in the microcontroller there is a one buffer, that is S buffer. Okay, now whatever data you want to transmit, first place into the S buffer. Then S buffer convert the data, 8-bit data, into the package as per our program protocol. Okay, that here data is converted into the package, means here S buffer add the start bit and stop bit to the data. Then 8-bit data is converted into 10-bit package, and that 10-bit package is transferred through this transmit pin to the other side as per the baud rate set by us. Okay, now one by one bits are out. Data 8-bit data is converted into 10-bit package. Now all 10 bits are not moving at a time because there is only single wire, and that's why one by one bit is out as per the baud rate. When all bits are out, and that time it will set TI flag, which indicate that all 10 bits are out and S buffer is empty for next transmission. In this fashion, when all 10 bits are out, that time only TI flag become 1. Up to that our TI flag initial it is 0. Okay, and when all your data fully out, that time TI become 1. In this fashion, data fully transmitted, it is reflected on a TI flag. Similar way for reception process. Suppose my controller want to receive something from the peripheral. For example, it want to read something from internal device or from the memory. In that case, whole data is not coming at a time because there is only single wire. In that situation, data is coming converted into the 10-bit package, and that is 10-bit package is coming one by one to the receiver side. When it is coming to the receiver side, that time one by one data is inserted into the microcontroller and it is held into one of the register. That register is called as a S buffer. In this fashion, one by one all 10 bits are entered, and that time RI become 1. Up to that RI is 0, which indicate that reception is not completed. When RI is equal to 1, which indicate that your new data is fully arrived inside the core. In this fashion, data transfer completely or receive completely or not, that is reflected on TI flag or RI flag. When their respective flag become 1, which indicate that particular action done completely, and this is done in a serial communication. Next register which is supporting serial communication, that is a SCON register. Now during writing a serial communication program, you are placing proper number in SCON register. SCON register is control register which is controlling serial communication. Now it is a 8-bit register. Now this is the structure of SCON register. Now one by one we will see again the same each register description explanation. That is bit number 7 and bit number 6 is your SM0 and SM1. Now SM0 and SM0 is for mode selection, serial port mode selection, bit number 0, bit number 1. The 2 bits are assigned for mode selection. 2 bits means 4 combinations are possible. That combination explanation is given here. When SM0 and SM1 are 00, that time you are interested in mode 0. When it is 01, interested in mode 1. 1 0 interested in mode 2, 1 1 interested in mode 3. In this fashion, you are choosing one of the mode as per your choice by placing proper number at these two locations, that is SM0 and SM1. Okay, now what are the features of each mode that we want to explain. Now in mode 0, features are in mode 0 our S buffer working as a shift register. Here both the data are in and out through RX pin, and TX pin is outputting the clock signal. It is working as a shift register. It is not using for communication purpose. Here it is just shifting the data. Here 8-bit data is transmitted or received, and here baud rate is fixed, and that is the 1 upon crystal frequency upon 12. Okay, now this is the baud rate is fixed here in mode 0. Now feature of mode 1. Mode 1 feature is here data is entered through RX pin, transmit through TX pin. Actually data is 8-bit data. That data is converted into the package by adding start bit and stop bit, and in this fashion 8-bit data is converted into 10-bit package. Okay, and when all data is fully transmitted, the TI flag become 1, and suppose data is fully received, RI flag become 1. Next, this is the frame structure for mode 1. Then next one is mode 2. Mode 2 is again data is received through RX pin, transmit through TX pin. Now in mode 2 your data is 9-bit data, and that's why actually S buffer handling only 8 bits, and 9 bit is not handled by S buffer register because its capacity is only 8 bit. 9 bit we can't place there, and that's why 9 bit is placed at TB8 location, which is the location in SCON register. Similar way, suppose you are receiving 9th bit during reception process, your data is 9-bit data. First 8 bit are placed into the S buffer, hold by the S buffer, and 9 bit hold in a RB8. Means for transmission process 9th bit hold in a TB8, for reception process 9th bit is hold in a RB8. In this fashion these are the location for the 9th bit, and first 8 bits are placed into the S buffer. In this fashion in mode 2 your data is 9-bit data, and along with start bit and stop bit, 9-bit data and 2 bits, it's become frame having 11 bits, and these 11 bits are transmitted or received in mode 2. And here baud rate is fixed, that is crystal frequency divided by 32 and divided by 64. In this fashion there are only 2 baud rates provided by mode 2. Then this is the frame structure for mode 2. Then mode 3. In mode 3 data is transmitted through TX pin, received through RX pin. Again in mode 3 there are 9 bits, and that's why 9 bit received, that is the 9th bit which you want to transmit, that is hold in a TB8, and on reception process 9 bit received, that is hold in a RB8. First 8 bits in S buffer, and 9th bit for transmission it is in TB8, for reception it is holded in RB8, which is available in SCON register. And then regarding baud rate of mode 3, it is variable. The difference between mode 2 and mode 3 is that only baud rate is differ. In mode 2 baud rate is fixed, whereas in mode 3 baud rate is variable as per our choice. In this fashion you can give the explanation of each mode, and according to that you choose your desired mode for your programming point of view. In this fashion I just given the explanation regarding different mode. Mode 0 shift register, fixed baud rate. Mode 1 8-bit UART, variable baud rate. Mode 2 9-bit UART with fixed baud rate, that is crystal frequency divided by 32, crystal frequency divided by 64. These are 2 baud rate only possible. And mode 3 9-bit baud rate and variable baud rate and 9-bit UART. Now next bit is SM2. SM2 is for what purpose? There is only one controller or number of controllers are there. For example, suppose there is only one controller, that time it is single processor environment, and that time value of SM2 is equal to 0 and SM2 is equal to 2 means multi-processor environment. All of you agree for this? SM2 decide how many processor or how many controllers are available within that project, okay, or within that system. Suppose there is only one controller and number of peripheral, SM2 is equal to 0, and there is number of processor you want to communicate between the two controller, and in that situation SM2 is equal to 1. Next one is REN, that is receiver enable. Okay, now suppose there are the situation that is microcontroller is doing some critical task and somebody providing the data continuously and it is disturbing the microcontroller. In that situation, the rights available in the microcontroller to avoid that reception, and this is done by making REN is equal to 0. When our reception enable is 0 means we are disabling the reception, means microcontroller will not, anybody are sending the data to the microcontroller but microcontroller is not listening that or receiving that data. By making REN is equal to 0, and suppose REN is equal to 1 means other peripheral providing the data and microcontroller is receiving the data, and means receiver is enable, means REN is reception enable. REN is equal to 1 means reception is enable. REN is equal to 0 means reception disable. In this fashion, enabling and disabling we can do with by setting particular bit at bit location number 4. Then bit number 3 and bit number 4 is TB8 or RB8. The TB for 8-bit data, no need of TB8 and RB8. For 9-bit data, for transmission purpose, you are taking help of TB8, and for reception purpose, you are taking help of RB8. In this fashion, it is just holding the 9th bit. For mode number 2 and mode number 3, there is no problem for mode number 0 and mode number 1. In both the cases, data is only 8-bit data. There is no use of 9th bit, and that's why this location we are not using, and that's why these locations are 0, 0. Similar way, TI and RI. TI become 1 when transmission is completed, which indicating that transmission is completed, and means initially value of TI is 0 and when transmission is completed it's become 1. Similar way, RI indicating reception process. When reception process is completed, new data is fully arrived, that time RI become 1. Up to that RI is initially 0. Initially RI is equal to 0, which indicate that reception process is not completed, and when RI is equal to 1, it indicate that new data is fully received inside the core, and then controller will read that data. In this fashion, with the help of TI and RI, we are just checking our transmission and reception is completed or not. Okay, now we cover all this part. Now actual programming of 80 to transmit and receive data serially. Now I am just explaining now algorithm, and this algorithm we are following for all the programs, and that's why it is very important. Okay, now first step for serial communication is that we must taking help of timer to set the baud rate. Now we want to use the baud rate. We want to set the baud rate with the help of timer 1, and in mode 2. Mode 2 is auto reloaded. Okay, means once you calculated the initial value of and that you are putting into the TH1, it is continuously hold that value and all characters will transfer with the same baud rate. Means every time we are not changing the baud rate, means one character is sent with the specific baud rate, for example 4800, second character will send with the 1200. No, all character we want to transfer with the same baud rate, and that's why we can calculate the initial value as per the desired baud rate and we are placing into the TH1. Okay, before that I'm using timer 1 mode 2, and that's why using the timer, and that's why I'm just selecting the mode with the help of T mode register. In T mode register, this is the structure of T mode register. Lower nibble controlling timer 0, upper nibble controlling timer 1. Here lower nibble timer 0, we are not using timer 0, no use of this. Okay, now we are focusing on timer 1. Okay, now last two bits of this two, that is M0 and M1, decide the mode selection. Okay, now we are interested in auto reloaded, that is mode number 2, and that's why I am placing here number 1 0. Okay, now the next bit is C and T bar. Here C means 1 means counter, 0 means timer. Now I want to use as a timer, and that's why I will place here 0. Gate, then you want to start the timer by software way or hardware way. Suppose this is 1, gate is 1, you are using hardware way to start the timer, and 0 means you are using software way to start the timer. Now in our program, for all our program, we are just using software way, and that's why I'm just placing here 0. I'm using counter, that's why this bit is also 0, and this two bits, that is M0 and M1, I'm interested in mode 2, and that's why I'm placing here 1 0, and that's why my number is 2 here, 0 0 1 0, that is 2, and I'm not using all these bits, that's why I'm placing here 0 0 0, and that's why my actual number is 20. I'm placing in T mode register to use timer 1 in mode 2. All of you agree for this point? Okay, then next step. In the next step, as per the desired baud rate, we are doing that calculation, and that initial value is hold into the TH1. Every time TH1 hold that value, and when one character is passed, again same baud rate you are placing into the TL1. Third step is SCON register setting. Okay, SCON register structure is mentioned here. Here SM0, and this is again SCON register is also again 8-bit register. Here first 2 bits for mode selection. Okay, now first 2 is for mode selection. Now I am interested in my data is 8-bit data, and I want variable baud rate as per my choice, and that I'm just calculated, and I place into the TH1. Means I am interested in which mode? Mode number 1, that is 8-bit data and variable baud rate, and that's why I am placing here 0 1. Then next bit is SM2. SM2 indicating there is single processor or multiple processor. In our case there is a single processor, and that's why I am just keeping this bit as a 0. Next one is receiver enable. Okay, suppose I want to transmit something, I don't want to receive others, that time I'm just making this bit as a 0. And next bit TB8 and RB8, there is no question because our data is 8-bit data, because you are choosing mode number 1, and that's why there is no question of TB8 and RB8, and that's I'm just placing here 0 0. Okay, now transmission process is not completed, that's why it is 0. Reception process is not completed, that's why initial value is 0, and that's why this number become 4. This is 0 1 0 0, that is 4, and this is 0 40. We can place into the S buffer, and that with the help of 40 you are choosing mode 1 single processing, reception disable, and all others are 0 0. Similar way, suppose I want to perform reception action, and that time I must make this bit as a 1, reception enable. Suppose I want to receive something from input device or from memory, and that time suppose my receive enable is disabled. In that situation this bit is 0, that time even memory transferring something, input device sending something, till microcontroller is unable to receive, because here receiver is disabled by making it 0, and in that situation you must make it enable by writing here 1, and that time my number become 50. In this fashion 40 and 50 we can write into the SCON register. This is for transmission and this is for reception. You can write this is for transmission also. Agree? In this fashion you can place either 40 or 50H into the SCON register. That is your third step. During every program you are writing this thing, common thing. That is, first one is in T mode register you are putting 20H. Then in TH1 you are you are just calculating the initial value as per the desired baud rate and you are putting into TH1. Then in SCON either you are putting 40H or 50H as per your choice. Next, fourth step, once your setting is over, parameters are set, then you start the timer 1. Now you start the timer by software way, and that's why we are just writing the instruction set bit TR1. TR1 is related to timer 1. TR0 is related to timer 0. But timer 0 we are not using. We are using timer 1, and that's why I am just writing instruction set bit TR1. Then next step, fifth step, then we want to transmit something. Okay, and that's why we want to check which bit, TI bit. Okay, TI bit is available with the SCON register. Okay, SCON register, out of SCON register I am interested in only TI bit. It's become 1 or no. Suppose the TI bit is no bit, means it is 0, that time you jump to this target. That target is here, means it will come back here, again check TI, means continuously it will check TI. It will jump, it will continuously remain in this loop and continuously check TI till TI remain 0. You will remain in the same loop, and when TI become 1, that time jump no bit. This condition fails, and that's why it will not jump to the same target. It will go to the next step, and we coming out of that loop and proceeding the next action. All of you agree for this? And once you done that, clear the TI flag for the next operation. Okay, once it is set, it is not automatically clear it. Just clear it with the help of clear instruction. Clear TI flag before next transmission. Okay, in this fashion, this is the basic algorithm for transmission process. Now based on this, I am just giving the problem statement and I am just giving explanation of that. Now my first program is write a program for 8051 to transfer letter S serially at baud rate 4800, and this S we want to send continuously. That is my problem statement. All of you agree for this? What is my problem statement? One particular letter, that is S, that I want to send continuously through serial communication with the baud rate 4800. Now according to that, as per the program, as per the algorithm, I am just converting the algorithm into the code. Now first, as per the first step, I am placing 20 into the T mode register, and that's why I am just writing here move T mode comma #20H, means you are choosing timer 1 mode 2, that is auto reloaded. Then as per 4800, we just calculate the thing. Basic frequencies to 28 kilohertz divided by 6 is nothing but 4800, and that's why -6 we are placing into the TH1. That is initial value placing into the TH1. Next one is third step. You are placing proper number into the serial SCON register to control serial communication. That is 50, means 8-bit data is there, one stop is there, and reception is enabled. You can write here 40 also, no issue. Okay, now set bit TR1, fourth step, that is start the timer with the help of set bit TR1. Means I am just converting the algorithm one by one as per the step into the code. Then once I just start the timer, my role is to place the desired number into the S buffer. Now what I want to transmit? Character S, and that's why that specific character I will write in a double quote. Okay, means ASCII value of S that is taken. No need to calculate the ASCII value, directly write the character in double quote automatically controller will take the ASCII value of S and into the S buffer. Then S buffer just convert that 8-bit data into the package as per the architecture, and one by one it is transmitted because you already started the timer. Okay, once it is over, once it is timer is started, our role is to check transmission is over or not. When all 10 bits are out from S buffer, that time your TI become 1. Up to that you are remain in the loop. Okay, and when TI is become 1, that time I am coming out, which indicating that my S character is completely out from the controller. Then TI get clear, then TI become 1. That time I am coming out of that loop. Once I am coming out of that, my role is to clear the TI flag, means ready for the next transmission. Means after S, again I want to send the next character. Now in my problem statement, I want to send the same character. Again I want to send S, after S, yes, 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 like that. And that's why I'm just clearing it, and then S jump again. Again place the new S in S buffer, again transmit. Then again clear the TI. Again jump here and again set S. And in this fashion, on the on the monitoring screen, we are getting the data S, yes, 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 like that. In this fashion, I achieved the problem statement, that is, I am transferring letter S serially at the baud rate 4800 continuously. This is the program. Okay, now according to the basic program, I just going for the next step, that is I want to transfer the new string, that is God, new message, that is God, that this string I want to transfer serially at 4800 baud rate, 8-bit data, 1 stop bit, and do this continuously. Means I want to display God, that is God, God, God on a screen continuously in a serial communication. All of you agree for this? Similar way, in one of the university exam, they want to display SPPU. This is the string, that is SPPU. This string you want to display continuously through serial communication on the screen with the specific baud rate. They are mentioning this type of numerical program statement in the university exam. In this fashion, they can give any message that you want to type continuously through serial communication. Okay. Now best, according to that, I want to write the program. Again, I will take the same algorithm. Okay. As per the first step, I will place 20 into the T mode register. As per the baud rate, -6 I will place into the TH1. Then 50 I will place into the SCON register. 50 means 8-bit data, 1 stop bit, and reception enable. You can place here 40 also, no issue. Then once you done that, start the timer. That is as per your fourth step. After that, take the first character into the S buffer. Now this character that is G. In a God, first character is G. Now ASCII value of G, that no need to calculate, directly write into the double quote. That time this G is coming into the S buffer. S buffer convert that 8-bit data into the 10-bit package, and then we are just calling the subroutine call instruction. We are called to transfer, means every time you are writing the same instruction again and again. First we are transferring 0, G, then O, then D. Means we are writing that instruction again and again instead of writing, and that time your program becomes huge. To avoid that, the sub program, we are writing one sub program and we are just calling that sub program as per our requirement. Means for example, suppose I want to transfer first S, transfer G, then I want to transfer O, then I want to transfer D. Means every time write the same thing again and again, I will write something somewhere else, and I am just giving the name to that sub program as a transfer. Okay, means for example, when I am just writing call transfer, that time my controller will jump to label transfer. Okay, this is unconditional jump. Okay, directly jump to transfer. It will not check anything. It will directly jump call to this subroutine. I'm just explaining the subroutine now. Transfer means my controller come to this label. Now whatever in accumulator is G is there, okay, and that G is coming into the S buffer. Then as a G data is converted into package, it is transferred continuously, okay. Once your G character completely transfer, that time Ti become 1. When it is not transmitted completely, Ti become 0, means you will remain in the loop. And when G character completely transfer, that time Ti become 1. That time I am coming out of that loop. I am just clearing Ti flag. It is ready for the next transmission process, and return instruction means I will go back to the main program again. I am calling here transfer, okay, means I'm just controller will transfer to that transfer instruction, execute the instruction, and when return instruction is there, it will come back to the next instruction. Now in next instruction I am just writing move S buffer comma 0, then call transfer again. Move transfer is coming here, accumulator data is coming into the S buffer, okay, then converted into the package. Then I am just checking it is fully transmitted, that is O is completely transmitted or not. Once it is fully transmitted, Ti become 1. That time I am coming out, clearing Ti, again return to the main program. In the main program again I am coming to the next location, that is move S buffer comma hash D. Now D is coming into the S buffer, then call transfer. In this fashion, instead of writing this 3-4 statement again and again, I am just calling the subroutine. All of you agree? Means suppose I want to write SPPU. Suppose there is a string of 7, 8, 9 characters. Every time we want to write the same thing again and again. Instead of writing same thing again and again, I am just writing somewhere else, and I am just calling, I am just giving label to that subroutine, and I am just calling as per my requirement. Means suppose I want to write SPPU, okay, and suppose you want to write PCCOE NICD, okay, that string you want to display. That time, every time, not need to write the same instruction again and again. We are writing somewhere else, and every time we are just calling that subroutine, that is transfer. You can give any name to this subroutine, okay, as per your choice. And last instruction of subroutine is always return, and when return instruction is there, that time you are coming to the main program, the next location. And in this fashion, GOD is outputted to the output device. And once this is there, then yes, S jump is nothing but short jump. Again it is coming here, again it will transfer GOD, again S jump, again GOD, then GOD. In this fashion, we are just writing program to display GOD serially, to transfer GOD or GOD serially with a specific baud rate, and this is you want to do continuously, and that's why I'm just write here S jump again. Suppose I don't want continuous, I want to write only GOD single time. After this I will just write end, I will not go back, okay, I will not call S jump again, okay. Suppose suppose this statement is not there, that is continuously. Suppose it is continuously, means you must remain in the loop, otherwise just directly write here end, means end of the program. In this fashion, discover your second program. Now third program. In the third program, write a program for 8051 to transfer a string stored in the memory. Now my problem statement is I want to transfer a string which is already stored into the memory. I will take the string from the memory and I want to transfer it serially. Okay, again I am doing the same action, that is transferring out. Now for that, again I am writing the code as per the algorithm. First algorithm step is place 20 into the T mode. Why? Because we want to use timer 1, mode 2. Then as per the baud rate, I am just calculating the number, that is coming -6, okay, and that -6 is converted into the hex, that is coming as a FA. that is placed into th1. Then 50 I am placing into the SCON. Either you can place here 50, otherwise 40H, both are acceptable. Then start the timer. After that, I am just whatever string I want to display, I am just putting into the memory. I want to take the data and pass serially out. That is the problem, and that's why I am just in the memory, I am just writing one string. That is, this is a simple text. This is the one of the string, or this is one statement. Okay, that statement I want to pass out serially. Okay, this is the statement, or this is the string that I want to transfer serially. Okay, and this string having some name, and that is name is my data. You can give any other name as per your choice. Okay, means this is my name, this is the string, and this string is byte type, defined byte. Suppose your string is word type DW. Suppose it is double word type. You know, byte means 8 bits, word means 16 bits, double word means 32 bits. Okay, in this fashion you can write the string, and okay, and with this string having some label, and that is my data. Okay, means within the memory you are writing some label, that is my data, and within my data this is string is there, that is this is a simple test, this is the one statement is there. Agree for this? Now to this my data I am just connecting one pointer. Okay, and for that I am just writing here dptr. Now my data or my statement is inside the external memory, and that's why I am just attaching one pointer to that, and that is dptr, and that's why move dptr comma hash my data. जो my data का जो भी उसका एड्रेस होगा, it is coming into the dptr now. Then next, clear accumulator. Whatever in accumulator, clear it, because I don't want to make the illegal or unwanted thing, and that's why I'm just clearing the accumulator. Then I'm just writing instruction move C. Move C is related to code memory, accumulator, comma at a plus dptr. Now a is 0, 0 plus dptr. Now it is showing the first location of my data. Okay, that first character is coming into the accumulator. Okay, now first character is coming into the accumulator, and jump Z exist. Suppose your characters are over, then jump to the exist. Suppose all characters are not out till this is not become 0, then you will not follow this step, means you will not jump to the exit, you will follow the next instruction, and that next instruction is a call send. Means again if you are calling subroutine whose name is send. Okay, now what is the send subroutine? Now send subroutine is here. Now in send subroutine I'm just writing the program. Whatever data in accumulator is coming into the S buffer, then I am continuously checking TI flag when first character, that is this is the T is the first character, is entered into the accumulator, it is passed to the S buffer, and we are just checking fully T character is out or not. When T character is fully out, that time TI become 1, that time I am coming out of that loop, then clear the TI flag, and then return back to the main program. Again I am coming back to the main program, increment dptr. Now first character is out, now increment dptr. Now dptr showing the second character, then S jump again clear the accumulator, again 0 plus dptr means second location, data take the data from the second location into the accumulator. Then is it last character? No. Then call send, again it will come here, the second character is H is coming into the from this string, second character is H, and that's why this coming into the S buffer. Then again check fully H is out or not. When H is out, then clear TI, then return back to the main program. Again it will come here, increment dptr. Now increment showing the location of third character, then S jump again, Again clear accumulator, A plus dptr means third character is coming into the accumulator. Is the last character? No. Then call send. Means again in third accumulator, that is third character, that is I, is coming into the S buffer. Check I is completely transmitted or not. Then clear ti and then return. In this fashion, one by one character is taken. Now after this there is a space. Space is also having some ASCII value. Okay, that ASCII value is transmitted, and that's why we are observing here space. Again I, that S, then space A, space SAMPLE, space TEST. In this fashion, full character is transmitted completely, and then I am just checking, and that time suppose this full string is out, full statement is out, then jump 0, jump it, suppose it is 0, now it is fully transmitted, then jump to exit, and at exit we are just writing end the program. Means my full string which is stored into the memory, whose label is my data, which is pointed by dptr, that is fully outputted. Now end the program. In this fashion I am just writing code to achieve this statement, to achieve this task, that is write a program for 8051 to transfer string stored inside the memory. Now next, now transmission. For transmission 3 program I covered. Now I will cover next program related to reception process. Okay, now in reception process again I will just go through the algorithm again. In the reception process, first step is the same, that is T mode you are setting 20. Why 20? Because for serial communication we are taking help of timer 1 and mode 2, that is auto reloaded. Okay, and that's why I am just placing 20 into the T mode register. Again this is same as a transmission. Next one is I am just calculating the initial value as per the baud rate, desired baud rate, and that initial value I am placing into the TH1 holding that initial value, and every time it is updated into the TL1. Next, this step is also same as a transmission. Third step, that is SCON. Okay, SCON 40 means it has become disabled. We don't use 40 into the reception process. This is avoid this part, and every time SCON must be placed with the 50H. 50H means reception is enabled. Don't place 40 for reception task. Okay, otherwise even other device sending the data, controller can't receive it, and that's why it is compulsory SCON is equal to 50H only, because reception is enabled here. Here reception is disabled, and that's why you take care about this. For transmission you can allow both, but for reception it must be 50H only. No, don't place 40H. Fourth step, start the timer, same as previous one for transmission process. Now for only change in fifth step, here check RI flag. What do you mean by RI? Reception is done completely or not. Initially RI is equal to 0 means new data is not fully received. That's why I am remain in the loop. Okay, and when RI become 1, that time I am coming out of that, which indicate that my data is fully received, and that's why RI become 1, and that time only I am coming out of that. Means only change in transmission we are just checking TI flag, transmission is completed or not, and RI reception is completed or not with the help of RI flag. Only change is here RI instead of TI. Then once first character is received completely, we want to receive next character, and that's why we are just clearing RI flag before next reception. In this fashion we are just making few changes in the algorithm. Okay, then according to that new thing I am just writing the program. Now my problem statement is write an ALP, write an assembly language program. ALP long form, assembly language program. We are using assembly instructions. We are not writing program in C language. We are writing the program with the help of assembly language. Okay, and that's why ALP, that is assembly language program, to receive a byte of data serially, one by one data we are receiving serially, and put it in P1. Okay, for example, P1 having LED, LCD, some output devices are there. Okay, and on that I want to display something. Okay, for example, LCD is there. That time that first character display on LCD, second character display on LCD, third character display on LCD, like that. Okay, and now for serial communication, I want a baud rate of 4800. My data is 8-bit data and 1 stop bit. Now this requirement is given. According to this, I will write the code. Now, as per the algorithm, I am just converting one by one step into the code. First step is I will place 20 into the T mode register, then -6 into TH1, -6 why? Because I want baud rate 4800. Then I am placing here 50H, means 8-bit data, 1 stop bit, and reception enable. Okay, then start the timer, then continuously check RI bit. Suppose RI become remain 0, which indicate that process fully data is not received. When RI become 1, that time only I am coming out of this loop. Okay, and suppose your RI is 0, means reception is in process. Okay, and when RI become 1, which indicate that fully data get received, at that time the data is available in S buffer. Okay, RI become 1, which indicate that new data is fully arrived and it is available with S buffer. Now from S buffer take data into the accumulator, and from accumulator pass to the P0 or P1, where is your output device, and then remain S jump loop, again coming back in the loop, and we are doing the same thing again and again. Means one by one character we receiving, placing, coming into the S buffer, passing into the accumulator, and pass to the desired port, for example P1 or P0 port, whenever you want to transfer. In this fashion I am just writing the code. I am just converting the problem statement into the code as per the algorithm steps. Now next is, you every time you are just calculating the baud rate, but in some time you want to double the baud rate. Okay, there are two ways to double the baud rate. First way, we know that baud rate we are calculating from the crystal frequency. Crystal frequency divided by 12 is nothing but machine frequency, and UART frequency is divided by 32, and that's why it is coming 28 kilohertz. Yes, but suppose I want to double the crystal, I want to double the baud rate, means I must change the crystal, but this is not possible because our whole system is working on the same crystal, and that's why doubling the crystal, that is not possible, and that's why we are going for the other way, that is software way, to double the baud rate. And this is done with the help of PCON register. PCON register long form is power control register. We are just increasing the power. Okay, now in PCON register it's again 8-bit register. Okay, out of 8-bit register we are just concentrating on the high MSB, that is a D7 bit, that is S mode bit. Okay, with the help of S mode bit you can change the baud rate as you can double the baud rate. Okay, now there are two options. Suppose S mode is equal to 0, your crystal frequency divided by, that is normal, that is the crystal frequency divided by 12, then it is divided by 32, and it's become, that is 48 kilohertz. And suppose I want to double the baud rate, I am just making S mode is equal to 1, and that time initial crystal frequency is divided by 12. Now instead of dividing that machine frequency by 32, it is divided by 16, means divider factor reduced, means frequency get doubled. Okay, according to that, crystal frequency divided by 12, that is fixed, that is 921.6 kilohertz, that is fixed. Again with the help of S mode is equal to 0, that time it is divided by 32, and that's why it is coming 28 kilohertz. And suppose you are placing S mode is equal to 1, that is divided factor get exactly half, that is 16, and that's why it become 57 kilohertz, means it is exactly double of this. And according to that, we just placing the different number into the TH1. For example, TH1 is -3, S mode is 9600, that time 28 kilohertz divided by 3 is nothing but desired frequency is 9600, whereas S mode is equal to 1, that time I want to generate, I am dividing the frequency by 3, that time I am just getting how much frequency, 19200, that is double of this. Suppose I am placing, I want 4800, that time I am dividing by 6 normally, okay, that is normal, divide by 6, but I want double the frequency, that time I am just making S mode is equal to 1, that time it has become 9600. In this fashion you can double the baud rate by just making change in S mode register, which is available in the T-Con register MSB. This cover your serial communication.